everyone. Welcome to this new episode of the Swift Academy podcast. Today, I'm very happy to be with Matt Massicotte, who is former iOS engineering working at Apple, and also a developer at Twitter before, and now it's very contributed to the community and also for the Swift evolution, especially to topics related to Swift concurrency, isolation, actors, stuff like that. And really, I'm very happy to be with Matt. I really appreciate that he accept to be my guest in this special episode of the Swift Academy podcast. Hello, Mike, and how are you?
Hello, Eli. I'm very good, and thank you so much for inviting me. That was a wonderful introduction. I'm very happy to be here, and I can't wait to talk about this topic.
Thank you, Matt. Really, it's amazing topics and also difficult topics.
Yeah,
So it is not an easy topics.
that's
As
definitely true.
we as we prepared the episode with you before, in I think in 2 weeks ago, we speak about that Swift concurrency come with, I think, a little bit of terms of what we call, compared to, for example, Swift UI. We have a lot of things related to the API, etc. But it's my feeling, maybe the feeling of the majority of the community of Swift developer, there is a lot of confusion about some topics related to Swift concurrency that will try in this episode to maybe reduce these confusions and to understand things and to have this what we call philosophic approach to understand the Swift concurrency. Not all the concept, not all the topics, but we try to handle and to speak about some topics, especially related to isolation, kinds of main actor, custom actors, and the main topics also for me, it's the approachable concurrency that
Mm,
you spoke about this in the Swift connection in September at Paris.
yes.
I wasn't there, but I watched I watched what your the video in the Swift connection. It was really really hard to be honest.
Okay, okay.
Okay, and that's why maybe we need to speak what is isolation first, because
Yeah,
we
we can
came to
start.
speak about with basics, because I think that coming to the basic, maybe after this we can speak about the relation about this concept of and the threads. If Swift concurrency it's related to correctness, about then performance, this kind of question that came to my mind when I think about isolation, Swift concurrency in this. That's why maybe you can make a little bit introduction about what is isolation and how we can realize that the isolation is a real concept comparing to something related to threads, etc.
Absolutely. So, how I usually talk about this topic is that before Swift concurrency existed, we were all still making apps, and we were, in many cases, using GCD, Grand Central Dispatch, along with maybe threads in some way to do background work and to just manage our application doing more than one thing at the same time. And I think
Mm.
most developers that do feel good about that, or if they don't feel good, they tend to learn it relatively quickly. And then they move over to what Swift concurrency's implementation is and tend to struggle a lot. And I think this is interesting because there's almost, and people don't even believe me when I say this, there's almost nothing new. Everything that was there before, in fact, like where does Swift concurrency even come from? Where did the ideas that go into
Yes.
Swift concurrency, like isolation, where did they come from? They all came from observing how applications currently work today. How do Apple APIs currently work today? And how can we take this existing functionality, a lot of it was convention to keep things safe. How can we take those conventions and turn them into something that the compiler can enforce so that you can't get it wrong? And I'll give you an example. You asked me about isolation. So
Yes.
most people understand that you have a user interface and it has to only be touched on the main thread. And if you do
Yes.
let's say some networking work, some networking operation, when that's finished, you're going to have to then return to the main thread before you update your UI,
Yes.
right? But it's easy to forget. Then the compiler didn't know that was the case. You could just forget to do that. And even worse is, often if you did forget and you updated your UI in the background, it would be fine. It is not a
Mm.
certainty. Just because you're doing something that could be wrong does not mean it will actually cause a problem.
Especially when we come from UI kit experience with the background thread and the UI, the main thread, because a lot of problems come because we are not in the main thread. That's what this kind of idea was kept in the mind of a lot of developers that, okay, we should be for UI in the main thread. I
Yeah.
understand.
Yeah,
But
and this is tricky. This is especially tricky because most kinds of problems, you're looking at the code, maybe you're running things in the simulator or on device, and either things work or they don't work. It's very unusual to say, well, you're accessing this variable in the background thread, and only one time out of a million will that cause a problem. And then what
yes,
problem will it cause? Will it even cause a problem at all? Maybe. What problem will it cause? Many people believe that this is called a data race, the idea of that more than one thread can access a memory location at the same time. And the problem with data races is they do not guarantee there's going to be a crash.
yes.
There can be many things that can go wrong. In fact, the normal case for data races is it corrupts the memory and then it just sits there. And then later on, something else tries to read it and it gets a bad result. There's no crash. Maybe nobody even notices. In fact, it's possible to corrupt something in a way that you never read it. You then write to it again and nobody even noticed the corruption. Data races are so tricky because they are completely not deterministic. In fact, it is possible to get a crash report and it be caused by a data race that happened hours before that crash happened. It just silently corrupted some memory and it just sat there waiting. And then much later, you navigate to maybe the settings part of your application. You try to read from your database. It reads that corrupted memory and now you crash. And the crash has nothing to do with the underlying problem. It's completely unrelated. It's a victim of some sort of other, or I should say more like crashes always are effects, but what you want is a cause. And data races, it's very hard to find the causes. So this is like the motivation. This is why Apple started getting interested in doing this. The other reason why is they're really common. Like I am surprised how common data races are. When I first started working on concurrency professionally, I kind of assumed it would be a rare thing. But as I start looking through code bases, especially larger code bases, you find code that is accessing main thread only data in the background everywhere. It's like extremely common.
Yes.
It's also extremely common for applications to find out later. They didn't realize because of this like chain of, let's say, callbacks, many people don't even realize actually this code does need to be only accessed from the main thread. And I didn't realize that. So you kind of like, you can discover things about your own code base that you didn't realize. I think this is just fascinating. You can discover stuff about your own code base that you didn't realize when the compiler is starting to give you this information.
Yes.
So that's kind of like a background for why was this something that they were even interested in investigating.
That's great.
And then the design, like Swift Concurrency design, it came from observing how Apple's current SDKs actually work. The main thread is like the best example. Everything has to happen on one single thread, but it's just convention. You have to know this, and then it's up to you to make sure that you do that. And there's this there's another component that gets tied into GCD. GCD has a main queue that behaves very differently from all other queues. It is a queue, but it always guarantees that its bodies execute on a specific thread. And in general, queues don't do that. It's the only one that does. And so Apple has this problem where they're like, we want to start talking about some system that can maybe move these problems from runtime issues into compile time issues. But how do we talk about this? Do we use the word queue? Should we use the word thread? Because there's both. Our system uses both already. And then there's more. There are many systems that rely on locks. There's a lot of different terminology, or a lot of different, implementations that exist today in Apple's own SDKs and other apps for protecting thread safety. And so they came up with like a mutex. And so they came up with an abstraction. Instead of having to always use the word thread or lock or queue, we're going to say isolation. Something is isolating that data, surrounding it with this level of protection. And so it makes sure that it can't be touched by other, let's call them mutators, other systems that can change them at the same time. And that is what isolation is. It's an abstraction over the possible ways you can apply thread safety. That's it. That's what isolation is.
Thank you. When I read one of your article about isolation, there is a kind of types of isolation. We called static isolation, dynamic isolation. This come from your perspective or also exists in documentation of Apple? Because especially for the dynamic isolation, honestly, I didn't understand very well. It's at this time, especially related to what we call callbacks, etc. And for the static isolation, can you maybe introduce this kind of different type of isolation. And for me, it's very important when I read your article about this kind of different type of isolation and why understanding this can influence our comprehension and using of tools related to Swift concurrency.
Yeah. Okay. So isolation is a concept. It's about describing how you protect some data.
Okay.
But
It's
then
very
there's the specifics. Okay, that's like the idea, but how do we apply that to our code? And so what Swift has done is move this information into the type system. So before, you had to know that Swift UI views can only be touched on the main thread, and that if you do some networking work, you have to go back to the main thread. They took that information that you just had to know, and they moved it into a little decorator called @main_actor that they put over the type, and then you
Yes.
can't get it wrong. That's where that lives. It's kind of like documentation. Instead of you having to look up, oh, is it true that this callback happens on the main thread? You now can't get it wrong because that documentation, that @main_actor annotation, is in the code. That is known as static isolation. When you can put that information into the type system, it is static, it is unchangeable, it is part of the source. It doesn't matter what's happening at runtime. What matters is what we were looking at, what the compiler is looking at build time.
I have a question about this.
Of course.
When we have this kind of making @main actors, behind the scene, we have, like of mutex that handle and sure that we didn't have this kind of data races, or what is the mechanism behind the scene of using @main actor? Because when you have the kind of property wrappers, kind of @main actors, something like that, we have a code behind this. And this, we have mutex. What kind of code exists behind the scene?
Yeah, this is a good question. So with GCD, we would use it's dispatch queue.main queue or main, dispatch queue main, excuse me. And so that's what would result in moving code into the main thread. There's actually, in terms of protecting stuff with main specifically, there's no real mutex involved. The strategy that they use is we're worried about more than one thread accessing the data at the same time. And so what we're going to do is we're going to say, we're only going to have one thread. Everything is always going to be accessed from the same thread. It's impossible to have a data race because you need more than one thread. And that's what main actor, the main queue, what the main thread, that's what it's doing, is it's eliminating data races by eliminating all threads except for one. Now, you asked the question, where does this come from, the implementation? And I said that isolation is just an abstraction over a way to protect data. But an abstraction, what is the concrete implementations? Those are actors. So the compiler does not know how main actor works. It just knows, I understand what isolation is. That helps me reason about how these types can interact. And I know that main actor is an actor, and actors are the things that implement isolation. But what the compiler doesn't know is how the main actor does it. It doesn't know that internally how main actor works is it makes sure that any job that it has to run happens on the main thread. That's the job of the actor. And you could make another actor that does something in a completely different way. And that's fine as long as it maintains the guarantees that an actor needs to. So isolation is like a concept, and an actor is the thing at runtime that implements that protection that it needs to do.
Great. Yes, great. We have to speak about the static isolation. Maybe my question to speak about difference between static isolation and dynamic isolation.
Yeah, so static is about the type system. It's about things the compiler understands. The static part means does not change, does not depend on runtime. We can look at the code, and this is what the compiler is doing. The compiler is looking at your code and saying, I see a main actor right there, and that means there's a guarantee that it will always be accessed by this actor called main. That's all static, things that do not change at runtime. But there's lots of code, maybe because of you're in the process of a migration. There are situations where you cannot. Swift concurrency is actually limited. This is another thing that surprises people, but there are more kinds of concurrency in Apple's APIs than the language can express. There are situations that are not modelable. They did a lot. They were able to model many, but not all. So there are certain kinds of situations where you cannot express what is happening at runtime using the type system. And in that case, one tool, there's a number of tools you can use, but one tool is called dynamic isolation. And what it really is telling the compiler, you can't see, but I, the developer, am telling you actually at runtime, this is going to happen on the main thread, for example. And that's the idea of you're adding in this dynamic component. The compiler cannot tell by looking at the code what's going to happen, but you are making a promise that at runtime, the dynamic part of it at runtime, that you do know what's going to happen. And that's the difference. Static is type system, visible to the compiler. Dynamic means runtime, only the developer could possibly know.
I have a question about this. The kind of when you make at no isolated for some property or function, can we describe it as a kind of dynamic isolation or something it's not really?
So
Because
using the type system, that non-isolated is visible to the compiler. It's part of our source. It is a static construct.
Mm.
Anything that uses a keyword or an attribute, those are all part of our source. So they have to be static. They don't change at runtime.
I have a question about what we call isolation inheritance, especially related to protocols. Because when we have this kind of protocol or classes, subclasses, how we can handle, first of all, this kind of concurrency inheritance, it's not very clear for people. And
you know what's
also
funny? It's true. You do understand it. I tell people this all the time. You understand it, but you just don't realize, because we don't usually think about this. We don't usually think about what our code is actually doing at this level. We're so used to using dispatch and controlling everything through execution. We don't even think about these new things. And what Swift did was it formalized so many ideas, but also introduced more. So I'm not certain this is 100% true in all cases, but I think it's good enough to give you a good idea. Is that we used to only care about what's going on inside functions. Inside of our function bodies is where we would make the method calls. It's where we would do background work. Inside methods or inside function bodies was all that there was. And that is where, in terms of concurrency, in terms of controlling our concurrency, it mattered what our code did. And what Swift added was now it matters what's going on outside functions, function signatures, type declarations. Those now matter just as much. And which is interesting because before it never mattered at all. And now it matters so much for how concurrency works. So, and I think about those two things very separately. So stuff that's going on outside of functions, like protocols, for example. Stuff that goes on outside functions, for the most part, I actually don't think you even want to use the term inherit. There's a term called inference. And so this is the compiler is looking at your code, and it's trying to understand what is the static isolation. And it goes through a very predictable algorithm. It's a lot like if you're looking inside of a function body and you want to decide what is self. Okay, you figure out what's the type of the what is the function? What is it a type of? Maybe it has a protocol it inherits from. Maybe it has a base class. But you can figure out by looking at the code what is self. And that is very similar to what goes on to determine static isolation. It's in many cases, it is the exact same process, except now the compiler also has, that's inference. What is the isolation here? It's looking at a function. Everything has isolation. Maybe it's main actor, maybe it's non-isolated. That process is called inference. And pretty much it involves protocols as well. When you're looking inside of function bodies, right? You make a function call. Now we start talking about inheritance. The idea is if you started on the main thread and then you make a function call, you stay on main. And then if that makes a function call, it continues to stay on main. And Swift formalized that idea as inheriting. Callers, this is for synchronous functions, callers just inherit the isolation. If you call me on main actor, I will remain on main actor.
Yes, it's great.
So that's inheritance, is more like what's going on inside functions. And inheritance gets complicated because closures are complicated in reality. And so it can start to become actually quite difficult if you need to understand all the possible rules of inheritance. I'm talking about isolation inheritance, how the compiler decides, and this can have both a static component and a runtime component. It can get tricky, but luckily for most code, doesn't matter. It's actually quite unusual for you to actually need to understand deeply how this works in all possible situations.
And especially for closure, etc., because we have a lot of legacy code that using closure and the impact of isolation, and especially when we try to migrate from strict Swift concurrency, like in the new Xcode, etc. What kind of challenges that you developer can face it with closure, especially when try to use a concept related to Swift concurrency from your experience?
Well, for the most part, closures are not actually all that special. You have a type and you want to decide, actually, this type is only safe to use on the main thread. So I'm going to put main actor. You have a closure. It's going to always get called back on the main thread. You add main actor to it. It's very similar. There are more situations because, like networking, for example, if you have a URL session, its callback in the callback-based system is what's called a sendable closure. And that means that you package some stuff up, you pass it off to URL session, and it is going to eventually run that closure on some background thread. It will not run on the main thread by default. It can be moved around. It
Okay.
has to be formed somewhere, and then it has to be sendable. It has to be sent somewhere else. And that is kind of that's like the whole heart of the system. And for most developers, most kinds of code, especially with callbacks and closures, you're really just deciding, does this closure have to be called on the background? And if it does, it has to be sendable. Does it guarantee that it always gets called on the main thread? If that's the case, you put main actor. And then if neither of those things are true, you can usually just leave it with no annotation at all. So for most code, now it
Yes.
can get much more complicated than that because the realities of how concurrent code can work can be very, very complicated. And so sometimes it is necessary to express more complicated situations. And that's something that I think you want to avoid until you feel better about the simpler cases. First, understand why you would put at sendable, at main actor, or nothing at all. And if you feel good about those, then you can start exploring some other tools if you really do feel like you need them. But a lot of code doesn't.
It's very important to distinguish between sendable and how to use sendable and main actor. Especially, we faced this using AI with this code generation, etc. We faced that sometimes some LLM come to use main actor and other for the same code, and others use sendable. And what make me a little bit fair about this, if we can't understand when we should use sendable and when we should main actor, can have be just accepted the purpose of the LLM and said, okay, he can use main actor, sendable, etc., without understanding really the difference. And for me, it's very, very important. That's why it's very important to me, and so I think for the community to understand this, to distinguish between when we use it sendable and this concept of sendable, what we send when we speak about sendable, etc., because we make sendable, okay, sendable. That's to guarantee that the compiler it's fine with us, no problem. Just for to said, okay, this is sendable. They handle isolation, no data races, and that's all. I think that for the majority of developers, they didn't understand first of all the origin of the name. Maybe I'm wrong about sendable, and also the difference between when we use sendable and when we use at main actor. Maybe and you are okay with me with this.
Well, yeah. So, okay, so we were talking about how isolation is this abstraction, right? It's a way of saying a thing that protects data. But what data needs to be protected? Lots of data, like, doesn't need protection at all. You don't need to protect ints. They're immutable, and they hold just a value. And there's lots, if you look through your code, it's actually very normal to have lots of these data types. Maybe you decode them from JSON. They hold just data, and they have no behavior or they have no references to any other types at all. So lots of
Mm.
data has the same kind of property as an integer in that it is completely thread safe inherently. And that is
It's because it's not no mutable. That's why we didn't have to add this.
immutable is not enough, but it's a start. It is a good start. So yeah, but an integer is like a very interesting starting point because it is both immutable, but it also has no references to anything else. It is just a value.
Yes, Vesha
And so
value.
that is safe. Now, the thing about isolation is protecting data, but what data? We don't need to protect ints. In fact, there's lots of data we don't need to protect, and we call that data sendable. Sendable data doesn't
Mm.
need protection. And that is the reason why the term was used. It actually came from Rust. So the term send came from Rust. But the idea is that if it's in one actor, it's under the protection of one actor. If it can leave, if it can be sent out of that actor, that's what sendable means. And I think it's
Okay.
more interesting to think about the other thing, which is non-sendable data that is
Yes.
not safe to leave an actor. That's the data that isolation is designed to protect. The only purpose of having if everything is sendable, you don't need isolation because everything can move anywhere freely. There's nothing to protect. You only need to protect data that is not sendable.
Yes, in kind of actors, etc. That's why I have one of my colleague sometimes said to me, I think that we need to have actors only for managers, kind of repository, etc. In the clean architectures and managers. That's why, okay, we can move to make actors because we have maybe a kind of data races that come, but for the rest, why we need to speak about actors in view models?
Well,
I
what's
think
an
it's
actor?
accepted.
Right. So let's
And
talk more about what's an actor. I think that
actor.
I made a joke one time, which was every actor needs a comment above the declaration that explains why it's an actor, and it's not allowed to be because it makes the compiler happy.
Yes.
So if you're going to use an actor, I think it's reasonable to justify why are you using an actor? Actor is a lock. An
Yes.
actor is a queue. An actor is a thread. I mean, that's not exactly true, but kind of. It's an abstraction. So why are you introducing an actor? So if you wanted to use an actor, it must be because you need to protect some data. That's the only reason you would ever need to have an actor. And then the next question is, and that's good. I like actors because actually using locks or queues manually is hard. It's very easy to forget to do the right thing in your code. Notoriously difficult, actually, with locks. So actors are nice because the compiler does everything for us, but are there downsides to actors? And there's actually a lot of downsides to actors. One of the biggest one is because an actor defines its own little bubble of protection, it only lets sendable data in and out. So now more stuff needs to become sendable. As you use more actors, you're defining more areas of protection that require communication using only sendable types.
Yes.
And so the more actors you have, the more you get pushed towards having more sendable types, usually. I think a really good mental model for what is an actor, it's much more like a network service. So if you have an actor, imagine instead of having that actor in your code, it was some network service you had to call. You had to only use network requests to do it. First of all, you have to package up the input, you have to package it up and encode it somehow, and then you have to send it to the network service. Then you have to await for this result to come back, and then you have to decode the result, which gets sent back to you. And actors behave almost exactly the same. So if someone asked me, for example, like that you said this manager type should always be an actor, I think it's very reasonable to say, okay, why? Why not a main actor type? Is the manager only holding data that gets read and read from the main thread? Probably. And if that's the case, first of all, it'll be faster because you're not leaving and hopping back and forth from to and from the main thread. It also makes it much simpler because you're already on the main thread, so you can access stuff that doesn't have to be sendable necessarily from other main thread uses. Another huge advantage of using only main thread types is you can access them synchronously. You don't always have to use awaits everywhere from other main
Yes.
actor contexts.
I faced the same issue when with the framework that we wrote last year about the container of dependency injection. We try to make the container as an actor, and everywhere when we try to resolve or to register the developer that use this container, it's obliged to the need to add await everywhere. And I think, okay, but resolving dependency for me, it's a synchronous thing. No need to have await everywhere.
I mean, as soon as you use the word synchronous, that's the key. If you ever have the word synchronous, it's very common for someone to design a big system and they're very happy. They're using an actor. They're so happy with it, except this one spot. Or maybe there's a few little places and you say, well, I need to do a synchronous read right here, or I need to do a synchronous access there. As soon as you say synchronous,
Yes.
actor is out. Actor is no longer an option. You can't store that data on a remote network service because you can't read it synchronously.
Yes, great. And if we didn't use actors at this moment for kind of things that are synchronous, but also can face the problem of data races, like the kind of the container in the dependency injection framework, we have the kind of register, etc. We can face it to this kind of problems of data races. For synchronous things, using main actors, it's actor, so main actor, it's actors. There is
that's true.
Main actors and actors, the same thing. Maybe difference that maybe there is a difference. You can explain about difference about actors type, like a type, and the property wrappers or decorator that we can add to classes or struct, like the main actor. I think there is a little bit difference. And maybe you have idea about
Yes, there is. There absolutely is, because that's a good point. You're right. And so when you define your own actor, you're defining your own lock, your own private queue. Nobody else
Yes.
can ever have access to that queue. With a global actor, like main actor, it's a shared resource. Lots of other types can have access to the same queue. They can have the same actor. And it's this, so
Okay.
it's kind of like dispatch queue.main. It's a static variable that's shared among the whole process. And the same thing is true of a global actor. It's a shared resource. They can all kind of use the same protection in a collaborative way. And so that's an important definition, is when you declare your own actor, nobody can get access to that internal state but you. If you declare a global actor, other types can share that actor as well. Now, global actors have downsides, just like they have all the same downsides of regular actors, and more. So global actors you have to be extra careful with, but that's the way that Apple's SDKs worked. They worked with a shared thread. That was the model that already existed, which is why global actors had to exist, is because they had to figure out a way to model the reality of how their SDK worked today.
Okay, understand. Great, thank you. I think that little bit of confusion is much more clear for me now, and hopefully for the community. That's why it come to another question for me about Swift concurrency and isolation, like concept. It's about correctness or performance. I think it's for me, it's from kind of correctness, from a kind of okay, we hope handling this in compile time. We can be sure that everything is correct. We don't want to have problem at runtime. And this is the philosophy of Apple in Swift, and also that coming from our discussion last time, that come from Rust. Try to make this kind of protection at compile time. If there is something related to performance, if behind the scene we have this kind of GCD, dispatch queue, etc., I don't think that's a kind of improvement in performance, but in correctness, I think that things much better. Maybe I'm
Well, the
wrong.
motivation here for you're
Motivation.
100% right. The motivation for doing this was correctness. Now, it turns out that I would say Swift concurrency, like as a technology, is 80% about performance, about correctness. I'm sorry, but 20% of
Okay.
it is performance, because something that you will see, and this is very common, especially when doing migration, is that most applications have way too much concurrency in them. Way too much. People are spending way too much time and resources and complexity attempting to stay off the main thread for the purposes of keeping their application responsive. And what this results in is, like I said, it's an enormous amount of complexity that's hard to model using Swift's concurrency system. It's difficult to model complex arrangements using the concurrency system because they are complex, and that's just the way that it goes. And it has a tendency to, people go usually in one of different directions. In one direction, they're like, okay, we're going to have to make everything sendable because otherwise we'll never be able to migrate our application. And the other direction is, we're going to have to put lots of stuff on the main actor. And then we don't need to make things sendable, but we're worried now that we're going to be blocking the main thread by doing so much stuff on the main actor. And for the most part, that is not just unfounded, it's the opposite. Many applications begin to improve in performance as they put more things on the main actor. And the reason is they're spending too much time bouncing back and forth between background thread and main thread, doing absolutely teeny tiny amounts of work. So their application gets simpler, and that's good. That helps with migration. But it also means you're being more efficient because you're spending, I mean, don't forget, the CPU cores of these devices are incredibly fast. So you're spending, it's much more expensive sometimes to context switch. You're making the main thread wait, you're going and doing some work, then you're hopping back again. You don't just have to pay the cost and complexity, you have to pay the cost and performance too. And that is worth it. If you're decoding JSON, that JSON could be very big. That makes sense. But in many other situations, it's not just simpler, it's also faster to keep more things on the main thread. And so that's an area where I'm not sure not everybody likes it when I say that, but it is a way to improve the performance of your app by making it simpler, and having more stuff on the main thread often does work. There's another thing too, though, which is that actors, if you do have more actors in your system, they can do a much more cooperative form of multitasking. And so, like I said, switching off the main thread, there's a cost. It's called the context switch. It's very fast, but it's not free.
Yes.
But once you start doing work in actors, the change from one actor to another typically does not require a context switch, which is very less likely to be the case if you're using GCD. So it's easier to get better performance. If you're doing highly multi-threaded stuff, it's often, I find, easier to use concurrency, Swift's concurrency system, to get the best performance out of a system compared to GCD. The thing is that it's higher level. If you really want to fine-tune things very carefully, you will always do better with GCD, just like you'll always do better with less abstraction, going closer to the machine. It'll always be better performance at the cost, though, trade-off, increasingly more and more and more complexity. So I think for most applications, for most typical kinds of development, Swift concurrency is certainly about correctness, but I think it's good for performance too.
Thank you. When you spoke about actors, etc., we can have a kind of sometimes over-engineering at smells when we overusing actors in our code. You said that sometimes there is no problem because changing of context is not not a lot of time, and it's not very, especially with the new CPU, very fast, etc. No problem. But what kind of problems that can we have when we overusing actors, especially
the compiler will tell you. The compiler is going to let you know, because it's going to be very hard to build a system that works, right? You're going to have to make so much. you're going to have to make so much sendable types. It's going to push you because every time you introduce another actor, you need more sendable types. You need more awaits, more asynchronous. So the compiler is telling you this is becoming more complicated and you have to deal with it. It's kind of like when you said earlier, like, what about a type where you're not sure you want to use main actor, but you're worried about data races? Data races are the compiler's responsibility, not yours. You do not have to think about this. The compiler's job, its purpose, is to make it so that you can't have data races. So you just design the simplest thing possible, and it will tell you, you're sending a thing right here, and it's not a sendable type. It will tell you that information. So you, for the most part, just don't need to think about data races anymore while you're designing your systems. And I like to encourage people to be as simple as possible. If you want to introduce an actor, explain why. You have to have a justification to explain the reason an actor is necessary here. And I think it's much less common than most people believe. The reason I want to use an actor, and you want to explain the reason why. And I'm willing to accept the trade-offs of only asynchronous accesses, sendable in, sendable out everywhere, not being able to have access to that data synchronously anywhere else. These are all the kinds of things that you have to be willing to accept. And I think in most cases, actors are overused. I think actors are a very special tool and they have a place. I'm glad they exist, but I rarely use actors myself. And I think that they often it's just not a reasonable choice.
Yes, thank you. I have a question, especially when you speak about migration of the code. You know that there is a lot of legacy project now that using Combine, maybe it's Eric Swift, etc. They are not using the Swift concurrency basic. And when we try to migrate this kind of projects from using Swift concurrency strict, what kind of problems, especially when we have like operation, like in combine, merge, flat map, etc. Lot of calls of 2-3 calls to have the results. When we have this kind of using strict concurrency system, can we change our code? Because this operator in this operation like merge, flat map, combine latest, etc. with our legacy code, our code is not comfortable with strict isolation or strict Swift concurrency.
Well,
maybe you
okay.
face this kind, but because now I'm afraid because we have a lot of code using Eric Swift and also Combine, and we try, okay, even we now we change our default actor isolation to main actor. What kind of problem we can face it? And
okay, well, that's a separate question. I would love to talk about that, but let's start first. Wait, we'll back up.
Okay.
Combine or RX Swift. These are APIs. In fact, so is Dispatch. Dispatch, GCD, is the tool that most people used before this, is also an API. Swift Concurrency is at the language level. So any system, any API that you can write in Swift is almost by definition compatible with Swift Concurrency at some level. It has to be because it's implemented in the language. Now,
okay, great.
I'm not familiar with RX Swift, but I'm going to assume it has similar problems to Combine. So with Combine, Combine has many very serious problems. And one of the most serious ones is that Swift concurrency is all about modeling the concurrent behavior of a program using the type system. And Combine cannot do that. So fundamentally, Combine is incapable of expressing its concurrent behavior in the type system. If you put a little .receive on, it moves to the main actor. If you put a receive on background, now it moves to the... So it's kind of like, Dispatch has a similar problem. You have a queue, but is it a main queue or is it some sort of background queue? Those are all about values at runtime. And Combine uses exactly the same technique, which makes it very difficult. In most cases, it's impossible to express how it works using the type system. But that doesn't mean it can't be done. It's just a real pain. So it is absolutely possible. So I haven't had the chance to migrate an app using RX Swift, but I'm going to say absolutely it is possible. Unfortunately, it requires you, the developer, really understand where Combine has problems and how to address them. There are some serious problems potentially, and you have to understand them.
Okay.
But it's doable. Usually when I tell people, most people that want to start doing a migration to Swift 6 or to turn on strict concurrency with Swift 5, they also want to get rid of Combine at the same time. They say, okay, Combine is finished. Let's use async sequence. And you can do that. But you do not have to do that. And I think it is much harder to do both at the same time.
Because it takes a budget or so. How to convince the company to make this kind of migration? Especially when you have a lot.
That's a great question. So I think, why do you want to do it? I think one of the fundamental questions that I think is worth asking is, you have decided, for example, you want to move your code base to Swift 6. Why? What is the motivation? Why have you decided to do that? because it is taking on some considerable work. And every team has different reasons for why they might want to do it. But having a clear idea, because Apple's not forcing you to do this. So if you have a clear idea in your head, I've decided to take this work on because maybe I finished a bunch of big features and I'm having some problems that I'm concerned our data races. Maybe you just have some time and this is a good time to do it. Maybe you're worried about your code getting a little bit you just want to do some maintenance. You don't want to let it be left too far behind. We still have, Swift 5 will be around for many years. I'm not sure how long, but the Swift compiler still supports Swift 4. We have a long time before we are going to have to be forced to do this. I would guess another 10 years still.
Okay, it's fear about this because people can continue to have their code using Eric Swift or Combine without no problem. But also, it's when you said that it will be easy also to do this and to make the challenge to do, because when we are afraid of make changes, we cannot improve ourselves, etc. It's important to do this and to convince also the company and the product that we need to do this, because it will be time that we need to do, because the code people can, I know that for some company people can go away from the company because they don't use Swift Concurrency, because they use Eric Swift, etc. I know it's not easy, but to people do, but for some experiment developers, you need to have to be attached to the new kind of API, new kind of code, because it's important for them to progress, to improve themselves.
You know what I think the most compelling reason is? If you're talking to a manager and they're saying, we want to invest some time, basically tech debt. We want to invest some time in migrating our code base, and they say, why? I think a very compelling reason is to say, because especially junior developers, but all developers, they're going to use these language features regardless. And in many cases, they do not understand how they work. This is true. Many people start using Swift Concurrency and they have no idea how it works. And then they turn on strict concurrency and they say, oh my goodness, I have so many warnings everywhere. I better turn it off again and keep going. But you're still using the system. Strict concurrency does not change how the language works. It just hides warnings from you. So that's the compelling argument. The compelling argument, in my opinion, one of the most one is that our team is using this system whether they understand it or not. And making this migration will help them to understand it so that we don't do things incorrectly or worse, and this is very common, build systems that can never be fixed because they were built under assumptions that the language works a certain way and it doesn't actually work that way. And now that we've realized that, we now have to go back and start looking at redesigning some things. So identifying those problems, that's a serious issue. And that's why I think that's a very good argument to make if you're trying to convince people to do this, to do a migration like this. Now that brings us, go ahead.
From your experience, what is the best manner to do this kind of migration? Because we have also the production code that involved with the legacy without using strict concurrency or concept related to sendable isolation, etc. And people continue to deliver, and we have the legacy code increase every time. People also, they try to make the migration. You are comfortable with stopping code developing until we finish migration to Swift Concurrency, or you need,
I have never worked with a company. I'm sure people have done this. I have never worked with any team that has stopped work and just done this only. I've never seen it happen. It probably does happen, but I would never recommend doing something like that. I think what makes the most sense is to do something incrementally, slowly, but also carefully so that you understand how to proceed. Having a modular code base helps a lot. It's usually I don't know if it's critical, but it's very hard to migrate a large monolithic code base that is not modularized. But I wouldn't recommend stopping feature work and doing this.
Yes, I understand because why I ask this question, because generally there is a technical lead developer that come to make this kind of migration, and the other developers, they try to continue to develop using legacy things. This sometimes a frustration for developers, especially for juniors that come, now we need to work with concept related to Swift Concurrency, Swift UI, something like that. And you come, this only the lead developers, technical leader that do this. And what is your advices? It's not maybe the main topic of the episode, but advices for technical leaders, for manager to do this. It's for you, it's suitable to ask a junior developer or mid-level developer to do this kind of working, because it increases their confidence with the team, and also they have a lot of cognition about the code, the legacy code, etc. And also, okay, oh, it's very critical. We need to do this job by a senior developer, a technical leader, lead developer. They have a lot of knowledge about the project. And what is your approach? If you are a technical leader, what kind of?
Well, I've seen many. I mean, this is all I do is work with companies that do this kind of thing. And I think it is not a good idea. I would not recommend a senior person going down and making lots of changes and then they commit. Now we're on Swift 6 for this module and then they move on to the next one. I think this is a mistake.
Yes.
It is a thing that has happened. But the problem is that, like you said, other people on the team will now maybe not understand how to use the tools. Now, when you turn on Swift 6, the compiler is now going to force you to understand. So that you can't ignore the problems. Or at least it's harder to do that. But I don't like that approach. I think what makes a lot more sense is to do things incrementally. You can use there are some compiler settings you can use. You don't have to go 5 to 6. You can use some compiler settings to gradually turn on more and more checks. But I think a really good, very general approach is, if you have a modular code base, it's much easier to start with Swift 6 than it is to migrate to Swift 6. So for new stuff, do that, but you have to invest in understanding. It's going to slow you down at the beginning, especially if you have been using it with concurrency checking at minimal on Swift 5 and you don't really understand how the rules work. It's going to take you some time to understand, but I think you have to invest a little bit in understanding and you have to go slowly. I like starting from the top, from your most UI level code, because it's probably all main actor. And it's a very simple, most people, even junior level developers, tend to really understand main thread. Like, I've heard that so much. I know main thread has to be on the main thread. They all often also usually are the same people who try way too hard to move stuff off the main thread, which can introduce a lot of complexity. But starting there is a really good place because most of it is very unambiguous, easy. And then you'll discover, oh, our database layer has some issues. Maybe we need to put some Sendable here and there. And then there'll be a lot of really easy things to fix. And then over time, you'll find the hard stuff. And I think that the senior developers' jobs is to find the hard stuff as fast as possible and kind of come up with a plan. Why is it hard? Can we fix it? It is possible to have systems that are built that cannot really be fixed. And then if they can't be fixed, what tools are we going to use to to deal with this problem and go forward?
Thank you, Matt. It's really very important advices for people to want to migrate. And to come to the last section of our episode about approachable concurrency, because this concept, we spoke about this in Swift Connection last year, and especially approachable concurrency, this term of approachable. And I find it in the code of Swift Evolution. And first of all, what is approachable concurrency? And after that, maybe we can speak about in depth about approachable concurrency.
Yeah, okay. So Swift 6.0, which is now, I guess it's maybe more than 2 years old at this point, but 6.0 was the compiler version that kind of had the language model fully formed. But it was hard to use. But it was possible to use. Before 6.0, it was basically impossible to make a system strict concurrency compatible. But it was very hard. So 6.0 really finished the language work, but there were some areas that were difficult to use. And so the team came up with this thing. It's called a vision document. And it's a vision document describes a bunch of changes, maybe many evolution proposals, not just one. It's going to take a number of them. And they identified these very specific kinds of areas where people are having trouble. There was a number of them. But then what they did was they turned that into language changes and some new features. And in fact, there's 2 features really in particular. There's a number of them, but I think the 2 features in particular that are important because they really change how things work is this one called non-isolated, non-sending by default and main actor by default. These are separate things. Many people believe that approachable concurrency, when you turn it on, it turns on main actor by default, and that's not the case. It's probably one of the most commonly misunderstood things. All approachable concurrency is a setting in Xcode that turns on a bunch of discrete compiler settings, and it does not turn on main actor by default. And of the settings that it turns on, the only one that I would say really truly matters and really changes the meaning of your code is non-isolated, non-sending by default. Now, it's true, it changes how things work, but it probably changes how things work so that it works the way you might have already thought it did. So there's code out there that before this feature would have been extremely difficult, if not impossible, to make work correctly with Swift 6 without changes. But this change made a lot of code work the way people thought it already did. And so that's really useful because you have this code that is wrong and can't really be fixed. You turn this flag on, and now it works the way you intended when you were originally writing it. It's a very useful tool. Additionally, it solves a lot of other problems that we don't have to talk about, but they were difficulties in usability. But the really interesting thing about this particular feature is it comes with a migration tool, an automated migration tool.
Oh, okay. Great.
So you can turn this on, and what it does is it basically produces a warning for every single spot in your code that is ambiguous, and it asks you, did you mean A or did you mean B? And I'll be more specific. Did you want this function to run always on the background, or did you want it to run on the caller? Inherit the caller's isolation.
Yes. Yes.
Most people believe it was always going to inherit isolation. It's kind of very natural. When I call a function on main, it stays on main. When I call an async function on main, it didn't used to stay on main. And now
Yes.
it can.
Okay.
And so this makes the language line up much more with how people originally, their intuition felt like it should work, which is why the term approachable was used. They're trying to make the language work more like how you might have just thought that it worked. The idea was make it more approachable. This is distinct from main actor by default, which is different. It's not part of approachable concurrency. It's another tool. It was part of the vision document titled Approachable Concurrency, but it is not part of the setting, and it will never be part of the setting. This is a mode. It allows you to change a very fundamental thing the compiler is doing, and it's up to you whether you want to use it. I have found it to be very challenging. Most non-trivial projects really struggle to turn this mode on, and the benefit you get from it, it's really just automation. It's putting main actor in front of everything. So the benefit you get from it is usually fairly small, but the cost associated with it can be very high because it introduces a lot of complexity in some code bases that can be really hard to understand unless you really deeply understand how the concurrency system works.
Yes, great. I think it's much clearer for me, this kind of approachable. And I think it's kind of pedagogic things, this kind of approachable or long-term design direction. Maybe we think that when Apple try to give us this tool to, what we need to make inheritance, etc., this kind of tools can facilitate, if we can say it, reduce the complexity of using, but without understanding things, do you think that it will be easy or to be a lot of bugs when people didn't understand, just choose without understanding how things work?
Well,
yes.
So one of the nice things about the Swift 6 language mode, specifically, is it's very hard to introduce certain kinds of bugs that the compiler won't notice. So if you're worried about introducing data races specifically, that's the compiler's job. Now, there are other kinds of bugs that you can introduce, these things called reentrancy, actor reentrancy, because nothing blocks. Everything is constantly moving. It doesn't wait for you. That is the thing that was always the case. It was actually true for GCD as well. It's just that now it's really easy. So it's much easier to introduce those kinds of problems. But I would say that for the most part, the big bugs, the really terrible issues, they come from using the concurrency features with the checks off. So you're using Swift 5 language mode, you maybe have minimal, maybe even targeted, but you're using concurrency. If you're using the concurrency system, it's kind of like you've turned off part of the type system. And so that's where the really serious problems usually come from.
Okay. Understand much better. And that came from maybe my last question about the Swift evolution, if it will be forward for like using a kind of single actor by default apps, this kind of using actors. And you think that Apple encourage people to use actor or main actor everywhere in the application, especially imagine that now with the main actor for the iOS application. You think that this kind of it's thought by Apple to encourage people to do this, or what is the perspective about the evolution of using actors, main actors in our iOS application? Because I'm afraid that at the moment that we have a lot of main actor actors, etc. And okay, people didn't understand what is the purpose. Okay, we spoke about correctness, etc. But what I'm afraid it's especially that we can we come with the code with a lot of main actors without understanding the purpose. What is, for your point of view, what kind of correctness idea that Apple that can propose that people also increase their knowledge, the comprehension about Swift concurrency, isolation, this concept of main actor, etc., and have an idea about the evolution of Swift concurrency, especially in next version 6.3, something like that.
Okay, so I think we're talking mostly specifically about this idea of main actor by default, and if we
Yes.
can maybe, if that's going to change or how that's going to evolve. So right now, there are no plans to introduce anything other than a default of non-isolated, which is how it always was before 6.2, and then or main actor, which is this new option. And the intention, the plan is that that will be a mode forever. There will never be a third option, but also we will not be able, we can never move towards main actor, not by default, always, but just as a mode. So that can never happen.
Okay.
So I believe what we have right now with Swift 6.2's like model of it is going to be fixed probably for a very long time.
Okay, great.
Now, you asked a second part, which was kind of about like, how should this influence our code inside? How should we be writing main actor all over the place? Maybe we should use this default. New Xcode 26 changed the default. So if you make a new application target, it turns main actor on by default. I do not like this feature. I'm not a fan of this mode.
Okay.
I think that for most projects, it's not a question of whether you like it or not. For most projects, it's not tenable. It cannot be used because you will run into too many problems by doing it. Applying static isolation and this global actor everywhere is a big deal. It changes how the type system works in a very, very big way. And if you don't understand the implications of this, it will be hard to use. Now, Apple is going to do work. I'm certain of it. They are going to do work in their SDK to be more compatible with this mode. It's already started. I am also certain, but I have no concrete information to share, that there will be language changes to make that mode work better. Because right now, it also has language level issues. I think both of those areas will be improved. But like fundamentally, if you're asking me, what should I do for my own work? I have become more and more a fan of just keep it very simple. Do not use main actor unless you have to. If you have to, first understand why. Why do I have to? And if you find yourself putting I guess my big rule in terms of like design is don't use keywords unless you understand them. And if you find yourself needing to use one, and you say, oh, I think I need to put non-isolated here, take a moment, take 15 minutes or an hour or a day and invest in your own knowledge to understand why is that the case. And then you were telling me earlier about trusting LLM's output and not necessarily knowing whether or not it works.
Yes.
And on the one hand, it's kind of like a victory for Swift, because if you're able to make a system where it doesn't actually matter whether you know how it works or not, and it still compiles and it still works correctly, that's incredible. Yes. But on the other hand, you don't want to start designing yourself into a corner. You have 500 actors all over the place. Everything is sendable, and you're discovering that it's starting to become really hard to manage, for example, reentrancy, and you're not exactly sure how to even do that or why. This is a very hard problem to solve. You can't get rid of those actors very quickly. It can be difficult to do. So taking time to understand and keeping things simple, I think, is a very powerful thing. And I think that's the number one rule. My number one rule is you're not allowed to use keywords you don't understand.
Yes, I think it's very good advice everywhere. Not for Swift concurrency, for Swift UI, for UI kit, for combine, etc. You need to understand. I hope, especially with LLMs, it comes that people understand, because you know that this new revolution of artificial intelligence impact our understanding, and really it's very, very sad, because what I think that we will come with people that prompt to artificial intelligence and LLM without understanding.
Yeah.
And when we lost understanding, topics, I think that the humanity lost a lot of their intelligence about their value. I think maybe I'm skeptical about this kind of. That's why I try to understand, to invite people like you, Matt, to reduce this idea of, okay, it's easy, we accept everything, no problem. We make a main actor everywhere. We main actor without understanding, and people, maybe they are lazy to understand things.
Well, yeah, I think That's not necessarily bad. I share a lot of your concerns. I think we feel very similarly. You don't have to understand everything. This is another mistake people make. People think, I have to understand everything about concurrency. I have to know about static, dynamic isolation, and inheritance and inference. I have to understand everything. That is not true. You only have to begin to understand things when you have a real problem. And usually, you have real problems that come up because of complexity. So keeping your application simpler. Can I remove concurrency? Can I do less concurrency? Often the answer is yes, and that makes those problems go away. So
Okay.
I do think understanding is so important, but I also think you don't have to understand everything. It's rare that you need to understand everything. I learned something new about concurrency today. Just an hour before we started talking, I learned something new.
Okay.
And this is my whole job. All I do is concurrency all day long for years at this point. And I still learn new things because most people don't need to understand every single last detail. It's just not important.
Yes, I understand to do not understand. It's not important to understand everywhere because it's impossible. But my my fear is about that you accept everything.
Well,
And
yes, I
this
think that's going to happen. Yeah, I
yes.
think that's a certainty.
Okay, thank you, Matt.
Of
For
course.
people who want to follow you, I think that you have the community that follow from your website. I think Matt Massicotte also in on X now and also on
No, I don't
GitHub.
use X, but you can find me on massicotte.org. There's a number of other social media. Yeah, I can be found in other places.
We will share this in the description of the podcast with also other information about your blogs, your website, and people who try to follow you. And maybe we have another episode about another things about
That would be
Swift
great.
Concurrency. It will be great. We'll try to share first over this episode. We have feedback from the community, etc. I know that it will be great. People will appreciate this. Maybe we'll prepare some practical things from another episode, etc. I know you have some limitation about this. I understand. No problem with that. Maybe I will prepare from my side and we'll discuss this. And
Yeah, looking at real
it
code
will
would be
be
fun.
yes, it will be great. And I think that will be a great thing that I share also some thing with you. And with practical thing, we can maybe reduce this confusion and we keep this fascination and understand the attraction to Swift concurrency. I think great concept that come that Apple try to involve to improve every time and understanding this it will be great for every iOS developer. Thank you, Matt, and see you soon. Thank you.
Thank you so
Bye.
much.